G'day comrade subscribers. I thought it might be interesting. So this is the Exelvision EXL100 from France. Uses cartridges and can load via tape, and can also have a disk interface. I thought it might be interesting to make our own cartridges for this system. This is what a cartridge actually looks like. It's pretty neat actually. You push down, and out comes the edge connector, which then slides into here. So just imagine the case is on top of this, so this is what we've got sticking out. So we need to bear that in mind when we design the PCB. This is what the cartridge actually looks like inside. So this is the A side. We've got A1 through to A14, so it's 14 pins each side, and that's the B side. So that's the side that actually plugs in. Right, so this is on the top, that's on the bottom, and you can see there it's one of those epoxy blobs, so you can't actually see what it is. So that's what the actual cartridge looks like, and that's what it looks like in its case. So you can see here it's not actually that big, but obviously we need to make the cartridge bigger because, like I said, the case is there, so we need it sticking out at least so that we can pull it out. So I thought it might be interesting to do a video on designing the PCB, because one of the things we need to do is probably do a custom footprint for this edge connector. And one other interesting design aspect that I've got to remember, so this is the 5-volt line. Notice how it's a little bit shorter than all the other signal lines, and this is ground. Ground's the same length. So you can see that's obviously an obvious design decision made so that all the other pins, including ground, make contact first, and then 5 volts is the last pin to make contact. Even though, you know, you're supposed to not have it powered on, but I guess sometimes people will, so that's a design consideration to try and avoid any damage. So yeah, I figured out the pinout already in the previous video. So it's just it's a pretty simple design, so probably the hardest part is going to be making a custom footprint. So I thought that might be interesting. So let's get started then. Okay, let's get started. So I've got my KiCad project created. I've got the schematic. So I've done a little bit of work on the schematic. I've just basically added the pin numbering, pin names, whatever, and what signal they are, just to make it a little bit easier. Right, so what do we need to do? So a ROM cartridge is simple. It's basically a ROM and a connector, so an edge connector or something like that. That's essentially all we need to do. So if we have a look at, so these are all the EPROMs, or these are all the ROMs that I know about for the Exelvision. So you see it's 32K is the largest. So we've got Paint, I think that's a text editor. We've got Basic Plus. I don't know what that is. Logo. And then we've got some games. So we've got tennis, and then we've got some 16K and some 8K. So it can be a bit fiddly trying to fit all of that into the one ROM. So what we would normally do is convert these to 32K ROMs. So you can either, so we can open it up. So we can either basically just fill in all the rest with Fs, or what we can do is we can just duplicate it another 3 times. 1, 2, 3. And then if we save that, I'm going to save it back to the, so Wizard, and if I put that 32K, I close that now. Do I have Wizard 32K on here? There. So that's one way. So we could then convert all these to 32K, and that way it makes it simple to choose between the ROMs by using a dip switch or something. Anyway, so if we've got 1, 2, 3, 4, there are other ROMs, like there's a drum machine ROM, I think, and I think there's something modem, but I think you need the hardware for that as well, which I don't have. So let's just assume these ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 in total. What did I say? We could do 1 megabit was, so 512 was 2, 1 megabit's 4, 2 megabits 8. If we go to 4 megabit, we can fit 16. So, well, let's decide on something. Let's have a look. Unicorn Electronics. Let's have a look at Unicorn Electronics. See what they've got available. So we've got. So they've got 1 megabit. So 27C010. So they cost about $8, $6, $5. We just get a standard one there, so about $4 US, depending on the speed. Then we've got a 2 megabit, and they've got 4 megabit, or even 8 megabit. Wow, okay, for $10. So, what are they all? 32 pins. What should we design it for? Should we design it for all the ROMs? 27C040 or 27C02. Let's see what we've got in KiCad. Okay, so schematic editor. Let's have a look. 27C020. Yeah, okay, they got that. They got a 4 megabit as well. Shall we go for the 4 megabit? Let's go for the 4 megabit, shall we? 32 pins. So we need A0 to A14 for the 32K, and the remaining pins, A15, 16, 17, 18, are going to allow us to select 32K banks, so we can select the different ROMs. So A14 to A0 will be connected to the Exelvision, and these other ones will be connected to a dip switch or something on the cartridge. All right, well let's go for that massive one there. Now, for the edge connector, because this is just a logical schematic, so it doesn't have to relate in any way to reality. So if we have a look at connectors, so what we want is a 2x14. What's that? Okay, so this is exactly the sort of thing we want. So we've got an A side and we've got a B side, but we could also just make our own. We could make our own connector rather than just doing this one. We could just simply whip one up, and we could also add the signal names, which would make it a bit easier. So let's make our own connector. Where is it? There we go, Clueless Engineer. Okay. So let's, new symbol. Let's create a new symbol, sorry. Connector, symbol. Symbol name. So we'll call it EXL100 cartridge, perhaps. Yeah. It's a connector, so I think they use J for connectors. I think that's about it. There we go. So let's draw a box, some box, like so, which we can modify if we have to. And then let's add some pins. Now I've got a printout here. So we're just going to basically, oh, I can't go to it. Yeah, so we're just basically going to reproduce this. So let's put a pin there. So pin name, so pin number is A1, and pin name, well, it's not connected, so let's just put not connected. And it's not connected, it's unconnected. I think that's all we have to do. I think we stick it like so. And then, okay, so pin A2 is the A13 address. Actually, I wonder if I should just do lowercase so you can tell the difference between the address. Maybe I should do it like that. Yeah, I might put the terminology like that, lowercase for the pin number, so you don't get confused between address and pin. And then we continue on like that. So A3 is the A11. So A11 address, signal, A3 pin number. Sorry, you can see what I've made, the mistake I've made there. I don't know how important it is for the electrical type, but so in our case, I think, well, I guess technically it's bi-directional, but in our case, address comes in, data goes out. So I think we put that as an input, and same for that one, it's an input. Hopefully I've got that right, around the right way. It's input to our PCB. So and then A9. So I'll continue on with this. A4, and finish this off. And then once it's finished off, then we'll add it to the schematic. I just realised, so we can do it this way. So it follows A1 to A14, B1 to B14, or we could group the pins. So we could group all the address pins together, and we could group all the data pins together. That would make it easier on the schematic for connecting them up to the ROM. So I'll actually do that. So I'll rearrange. So what I mean is, so we need to move that down, and then for example, we'll have, so between A9 and A11 we've got A10, which is actually B4. So we'll put A10 and it's B4, like so. So what we'll do is we'll group all the address together, we'll group the data together, and then yeah, we'll use it that way. It shouldn't make a problem because the pin numbers will line up with the physical footprint that we're going to make, and the physical footprint's going to be in the right order. So this is just a logical way of looking at it. And here we go. So we've got all the address pins on one side, all the data pins on the other side, the ROM select, we've got 2 pins that aren't used. Should probably move that up a little bit. And then we've got power and ground from the edge connector. So, yeah, let's insert that over here. There we go. So now to connect them up. So what we've done before is we've used just labels, and we've stuck a label on here, so A14, and then we've stuck a label over here, A14, and we can do it that way. But let's try something different. We could try doing, using a bus. So with a bus here, so as you can see, what I should have probably done is put the address. Anyway, whatever. I've done it this way, so let's do it this way. They can all be on the one bus anyway. So let's go up and over here, and then down to here, and then we'll have one coming down here, like so, I guess. Something like that. So there's 2 types of buses. There's a vector bus and I think a group bus. So we can so by labeling them, so if we put a label on the bus here, for example, if we go D and then square bracket 0, 7, and stick that on the bus there. So that's made it into a vector bus. So it's going to have signals D0 to D7, which we've got here and we've got here. But if we want to, so we could just have two separate buses, I guess. We could have one that goes like that, I guess. Let's get rid of that. So we could have a bus that goes kind of like this. So that's the data bus, and then we could draw a second bus, I guess, like this, for the address bus, like so. So that's one way we could do it. Or if we just wanted to use the one bus, then what we can do is we can make it into a group of vectors, I guess. So the label, so let's just call it a ROM, let's just call it ROM, and then curly brackets, and then we've got the address vector, so A0 to 14, space, then we've got the data bits, space, and then we've got ROM CS signal, so we'll include that as well. So we want, say it's active low, so I'll put a little tilde, ROM CS, close bracket and close bracket, think like that. So actually it's, why don't we move, can we just move it like that? Yeah. Okay. So we should be able to have all of them on the one bus. Now to actually connect them up to the bus, what we need to do is we need to draw a wire, and then we have these bus connectors here. So they go like that. So that's how far I need to draw my wire, like so. There's probably some quick way of drawing all of these, I don't know. There is a quick way of labeling them, which I'll show you in just a second. So I'll just finish doing this one. Okay. And then do our little connectors, like so. And then we need to extend the bus down a little bit. Okay. Now, we put on, say, for example, D0, label that wire D0. And now we can just repeat, because they're in order, D0 to D7, we can now simply repeat. So on the Mac it's F1. So if I press F1, I think, yeah, D1, D2, labelled, done. And then I can do the same on this side here, so I just need to extend the bus. Well, let's kind of put it in the middle, I guess. So it needs to go all the way down, or it doesn't need to go all the way, just down to A14. It needs to go down here actually, doesn't it? Let's just stick it there for now. Okay, and then same thing, so I can never remember how long these are. Okay, so I've got the wire across, like so, and then, of course, I'll put them around the opposite direction. I don't know if I can, I think when you do the repeat, I think it increments. I don't think it doesn't decrement, does it? Alright, so I thought I was doing so well. So I should have, alright, let me edit, let me just save that. Okay, let's go back to the okay, so what so I should put them. Alright, I'm going to reorganize this. I'll be back. It hasn't taken me too long. It's just a matter of just pulling that one out, bringing that one down to here, put that one back in. Whoops. There we go. A0 to A14. There we go. Right, so I'll save that. And now I should be able to, if I go back to the schematic, so I should be able to update symbol. So value reference, just, yeah, if I just update. Okay, close, and there we go. Too easy. Alright, so now I'll be able to continue on and just quickly label these. Alright, so I'll get all those done. So we only need up to A14, so A15, 16, 17, 18. We'll need another part, so let's just actually put that part on now. We'll get like a dip switch. We need a dip switch. Oh, here we go, dip switch. I think it's a four-way dip switch. Looks like that'll do the job. Oh, I could have stuck it in here. Right, let's just stick it over there for now. So what we'll do for these ones here, A15 to 18, is we'll pull them up to 5 volts. So we'll pull them high by default and then switch them to ground. as required. So by default it'll be 1111, these addresses, and then we can adjust it. So switch, close switch 1, and which will ground it, so then it'll be 0111. That way we can select different banks. But yeah, let me finish off all this bus stuff, and then we'll do that. Yeah. I just realised there is a faster way of doing these lines. Of course, doing the same way as the labelling, isn't it? So I want to go to there, and then it's just F1. There we go. Okay, and I've done the labelling there. So now let's just do the labelling over this side. A0, like so, and then again repeat F1, and then just connect up to the bus, and that's most of it done. Oh, apart from the footprints, most of the schematic done. Okay, we just need to sort out the power and then sort out these address pins here. So what I wanted to do was basically I need to pull up resistor. Well, let's just draw. So we've got a bit of a wire. Then we're going to have a resistor connected to 5 volts. How am I going to? What's the best way to draw this? Let's just draw like that. So I'll put the label on like this. What do we need? It's A15 onwards. So A15. Alright, so that'll be A15, A16, A7, A18. And then we add a resistor. Like so. Should I go upwards or should I go? I'll figure it out. Anyway, and then that's connected to basically VCC, 5 volts. And then on this side, these are all connected together on ground, and that should work. So yeah, all right, I'll do that now. I think that is it. So programming pin not connected, data, address lines, power, VCC, and VCC on the cartridge edge, ground. ROM select, right, and then for the dip switches, so for these ones here, A15 to A18, allows us to select the different ROM images. So when they're open, these are pulled high, so these are all 10K. I've just hidden the, just to tidy it up, I'll put a little note, but yeah, so these are all 10K. So these are going to be pulled high unless you ground some to select the different banks. That's it. So I think, I'm not sure how much more I'm going to do tonight. We can start doing the footprints. So this one here we're going to have to create the footprint, but that's not a problem. So let's assign footprints. So the ROM is a 32 pin dip. So we go down to package dip, and we go dip dash 32, and it's a wide one. They've got a socket, so let's do a socket. Let's stick a socket there. Okay, now dip switch. So they don't have switches, so I think it's up here on buttons. Here we go, button switch. Okay, so let's see what dip. Okay, there's dip. What have we got? 4. Okay, by 4. So we've got through hole. Okay, so we've got piano. We've got slide, low profile. I'm thinking maybe piano. That's a little easier, and have it on the edge of the PCB. Maybe let's just do that to start with. Okay, we've got 4 resistors, so we go down to resistor, through hole. Of course we can do surface mount to make it a bit smaller, but through hole makes it accessible for everyone. So what do we want? So let's mount it horizontally. and I think they're about 6 mil. So if we do a pitch, I think 7.62 is too small, just be too. So let's just do a pitch of that one. I think 10.16. Okay. Apply and save. And so now it's just the cartridge edge connector. So actually we can have a quick look. Let's just save that. Let's update PCB. So obviously, yeah, we haven't assigned a footprint for that. Close. But that's what we've got so far. So we've got our little dip switch. We've got our EPROM, and then we've got our pull-ups, which actually look pretty big. Actually, I could maybe have gone a size down, but I'll figure out what the best way to have those are. Okay, and then of course we need to actually draw up. So let's just save that. All right, let's let's make a start on this footprint. So let's close that. Close that. Now let's go to footprint editor. So it's actually an edge connector is actually pretty simple. So I've got some examples here. So this is I got from GitHub. I'll put it in the video description. It's quite handy because it's got some like for example ZX Spectrum. So this is ZX Spectrum edge connector. So you can see basically we've got the pads, and then this is obviously looking from the top down. So if we flip the view, then we're looking from the bottom up. And let's do bottom copper, and then you can see, yeah, so we've got the underneath, and you can see we've got ZX edges back to front because we're looking from underneath up. So that's essentially it. So it should be pretty simple. So let's start. I've made measurements of the actual connector that's used in the Exelvision is obsolete. It's very obsolete in that I could find no mention of it when I was doing a search. So I've had to measure the cartridge itself. So I've got a picture, which I'll put on the screen now. Reminder to Brett to insert image. So assuming it's 2.54 mil pitch, so 0.1 of an inch, I've got the pads are 1.52 wide with a 1.02 mil gap. So that'll give us a 2.54 millimeter pitch between the centers of the pads. And then they're about, so I measured at 10 millimeters long, but take into account it's probably imperial. So I've gone for 10.16 millimeters long. And then the width is 34.54 millimeters. So that's 14 lots of pads and then 13 lots of gaps. And then the actual edge connector itself, the PCB, is about 38 mil, I think it was. And then special consideration for the 5 volt power, which is a little bit shorter. So let's do. Here's my library. So let's go for a new footprint. I think new footprint. Yeah. Oh, okay, let's flip the board view. Now this line here is important. So I've been working on this before. You need to have the edge connector touching this line at least, otherwise it won't work, from what I've found. So let's see, what is it? So it's an EXL100 cartridge. Alright, and okay, I won't worry about that. So up here we've got the pads, so let's put our first pad in. We're going to do the top, so the front, so looking down, so that'll be the B pads. So front copper, let's try that again. Okay, let's just stick that there for now. So we need to edit this. So it's a edge connector, and it is called B1. Rounded rectangle, so pad size Okay, so it is the width. Okay, so I'm going to do it vertical. So it's 10.16 millimeters, and yeah, and then 1.52 millimeters, and then I just need to rotate it. So I'll just do like that, and then I can just rotate it here like that. And it's B1 from the right, counting to B14 on the left. So let's just stick that there. Okay, let's make a copy of it. That's the other thing, make sure, okay, 2.54 mil grid spacing. So let's just check the centers. There we go, yep, so that's right. And what about that distance there, 1.02? Yep, that's right. Okay, so let's edit that. So that'll be B2, like so. And then we can continue on doubling and doubling like so until we've got all 14, and then we will do the underneath. So there, that's pretty much it. But again, we need to remember that the 5 volt line, which is B1, 2, 3, 4, 5, 6, 7, 8. So B8 is a little shorter, 9.28 millimeters. So this should be 9.28 millimeters. Okay, now as you can see here, it's no longer in line. So what we do now is just hold light, and then we do properties, and then we want to do a line, and then just a line to bottom. Done. So there we go. That's the top done. And again, we can measure it. So I reckon it should be from edge to edge, it should be 34.54. So if we go down here, so yeah, if we want to measure from there to here, 35.54. Perfect. That should be all good then. Okay, now we want to do the underside. So let's copy these, and then what's the easiest way to do? Flip the board view. So now we're looking from underneath. Paste those down. So actually what we want to do is, okay, what we need to do, I think I did see something here to change side. So we want to change, so at the moment I think it's still on the front copper, so we want to, alright, there we go. And now it's blue because it's on the underside copper. We also need to rename it. So to do a quick rename, I think renumber pads. Yep, so these will start from A. So if we just click like that, A1, B, A2, like so. And then we obviously need to change, there we go. And then we just need to change this one back to 10.16. Alright, and then align them again. Align to bottom. And now, whoops, it'll just be a matter of moving all up to like that. So now, that should basically be done. Let's flip the board view. I think that's done. So yeah, here we go. So this is, we've got, yeah, see we've got, yeah, I think, yeah, let's just do it like that. Because I've tried it before like this and it wasn't working. I couldn't figure it out. But I think we've got to be kind of touching this horizontal line like so. Alright, so let's save that. Let's rename it. Oops, let's rename rename footprint to XL100 cartridge. Okay, save, 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 save. Close that. Now if we go back to the schematic and we assign footprints. Now under my clueless engineer, get rid of the filter. EXL100 cartridge. Okay. Moment of truth. Update PCB. Alright. Okay, good. Okay, it's connected everything. Good. Close. Although, it doesn't seem to have connected very much. No, that's better. There we go. Alright. So, this is the wrong way round. View, flipboard. Hang on. That's because I'm looking at the wrong. There, okay, alright, that's a bit, yeah, okay. That's better. So, flipboard view. And then if we, alright, I'm pretty, okay, yeah, it's just a little bit confusing, isn't it? Flipboard view, okay. So there we go. Now, let's make the PCB. So what we need, again, so I know we need to measure up how big it all needs to be. Let's go do that. Here we are back at the Exelvision. So as you can see, there is quite a bit of distance between the actual edge connector and the outside of the case. So with our cartridge, pop her out, slide in like so. So we need, obviously, to there. Now we've got the infrared receiver on this side, so we've got to make sure that we don't, if we're going to make it wider, we can't make it too wide, we're going to block the infrared receiver. And then we've also got the joystick caddy there, so we can't go over this way either. So it looks like we're going to have to basically come straight out. I was thinking we could have it on the side like this, but no, obviously not. So we'll take some measurements, see how far we've got to go. Try and do this one-handed. All right, I'll have to put it down so I can do these measurements. But yeah, you can see what we need to do, what we need to take into account. Makes sense. Okay, now we can get started on laying it out. So I just want to check. So we've got a width of 50 mil. Let's just check how wide our EPROM is. 41 mil. Okay, that'll fit. So I think what I might do first is I might just draw a quick box. So maybe on user drawings, perhaps. Yeah, just to get an idea. So I'll just draw a box. So 50 wide, 50 mil wide. It won't be because obviously the pads up here is a little bit shorter. So that's got to be. So these bits have got to be 54 mil out because they won't fit in the slot otherwise. So let's just do 100 mil, 50 by 100 mil. Okay. So at the, where is the, what have we got? It's 54 mil to the, so that's, I need to mark that, don't I? Oh, there we go, I've marked it. Oh, I didn't realise I could do that. Oh, it's gone. Alright, let's just draw a line. Alright, let's just set that as the origin. So that means, yeah, so if I have a look down here, that's the X and the Y. So if I come down here to 54, I'll draw a line across there. Like so. So that is where, on the other side of this is the case, is the outside of the case. So we kind of want these bits here to be kind of like that, I think. We probably could put the resistors inside if we really wanted to, but I just want to keep them close to the switch. Like so. So that's roughly it. Okay, now let's draw our actual cartridge. So, how wide? Okay, so it was 38 mil. So the actual, this bit up here was 38 mil wide, and then it becomes 50 mil wide. So let's go to, where's our edge cuts? Okay, edge cuts. So the simplest way for me, I think, is just drawing a box and then a box, but I think that confuses things unless you can you do, what did I say it had to be? It had to be 38 mil. And how deep is it? 11 mil. Roughly about 11 mil. So that's, this is basically that here. Roughly like that. And then we would have another box. Basically, this, I need to be on that. I need to move. Alright, I need to move things around so that it snaps to the right grid. But then basically, if I could do that, I think that's one of the drawbacks. Well, it's not the drawback of KiCad, but it's not really designed for CAD like this, is it? So I think what I've read before is that you can do the design in a proper CAD program, and then you can actually just import it. But you know, roughly something like this would be our box, and then, you know, if I was using AutoCAD, then I would just you know, obviously just trim this line off. I don't think I can do that here. Oh, okay, of course what I can do is just draw the bigger box and then I just draw the smaller box on top. Yeah, of course, let's do that. So let's draw the bigger box. So we're on edge cuts. Okay, so this is going to be the edge of the PCB. So it's got to be 50 wide. 50 mil wide, and well, we can make it bigger. That's the main thing there. And then, oh no, what am I doing again? No. I was going to say, I think we can we draw? Let's just see, can we draw quickly? Finished, right. Can we, is it chamfer or is it fillet? Fillet lines, chamfer lines, fillet lines. No, we don't want to do that. We just want to basically just snap that off. All right, let me just draw this. I think the easiest way to do would just be draw lines. So start here, go up here, there, up there, there, like that. So I'll fiddle with that, and then I'll be back. Right, I think I've figured out in my mind what I want to do. I like to have little like indentations on the side as well to help you pull it out. So I'll draw those first. I'll draw some arcs, say 10 millimeters, like so. I know that looks pretty deep, but what I'll do is I'll actually draw the line up to there, sort of thing, so it's not as deep. I'll copy that, make one for the other side. Right, so now I need to start drawing. I need to intersect. So, section is, so it's going to be 83 in total. So I want it to be, so I've got 40, I've got 10, okay, 10 down there, and it's got to be 50 wide. Alright, I'll stop there for now. So I need to move this one over. So I think I can do it like this. Like so. Draw another line. I think it was at 10, wasn't it? Yep. I just need to move this. I think that was how long that line was there. Yep, 10. Let's just move, whoop, didn't mean to do that. Ah, that's right, because that's not really, let's just get that, nope. So what I want now is, I've done it before, how did I do it? So I had to shape modification, heel shapes, okay, I'll figure it out, okay. Now I continue on from here, so that's, let's draw a line actually so I know how far to go. So it's got to be, I'm going to make it 83 millimeters in total until we get to the edge connector. So go up to here to 83. Okay, so that's where I need to be. 83. I just wish it would stay there so I can see where I'm drawing from. And it's gone. Alright. We'll do it roughly. So roughly in line there. Go up here. I think it was roughly there, wasn't it? Okay. Probably an easier way of doing that. Roughly 83, it doesn't have to be exactly. Okay, so it's 88. So I can come back a bit. And then I want to go in. Let's see. So the edge connector bit is 34.5 millimeters. And it's 38, oh no, it's 38 mil, okay, so it's 38 mil wide, so I've got 12 mil, so 6 mil either side. So here, come in 6 mil, and then go up 11 mil, and then across 38. Like so, and down 11, across 6, and then I should hopefully kind of join up like that. So that's roughly my layout. So now obviously I need to get rid of those. I've done it before, I've done it on my, which one did I do it on? I did it on one of my other designs. So let me fiddle around with it and I'll figure it out. I think I remember what I did now. So what I did is I just grabbed that and I just moved it back in, snapped it to there, and then snap that to there like that. So I was just thinking the other way I could have done it is I could have just gone, so I've drew it quickly, drew the rest of it, and then I basically redrew it like so, but then that's, I think that's too deep, that's, you know, so I think, yeah, that's the way to do it there. So again, just grab grab that and bring it down, then it snaps, and then again here snaps, and then we've got our little holders. And then what I do is I just chamfer, fillet the corners. So if we select everything like so, and then we shape modification. Oh no, it's not heel shapes. No, okay, maybe it's too many. Maybe what I need to do is like that. Shape modification, here we go. Extend lines to meet, okay. 3mm, maybe 2mm. Oh, that's maybe a bit too much. But yeah, go around doing that so we don't have such sharp corners. And then we should be able to bring everything across and it should fit nicely. Alright, getting there. And here we go. Just about finished. Well, I haven't done the routing yet, but you see I filleted the lines 1mm so it's nice and smooth. Hopefully this is about how the edge goes. It looks like. I'll print this out anyway to compare. I'll just put some text on here, just showing the pinout. I've got my little finger grips on either side. I've made sure that the EPROM is more than 54mm from the edge up here so that it doesn't get stuck. Yep, so it's 56mm, so that should be okay. Well, I'll print it out again. I've changed this to a slide dip switch. And yeah, let's have a quick look at the 3D viewer. That's kind of what it looks like. So I've put some text on there so we know what pins are what. I think that's just about it. Alright, so I just need to do, I'll put a ground plane on. So we'll go, what was it? So we want to do draw a filled zone. And we'll just go, I guess, and yep, so we'll go for ground, this one here, like so. Try that again, so there, ground, connected to ground on the bottom side. Stop snapping. Go down to here. It's snapping again. Something like that. Over to here. Stop snapping. Come on. Sorry. Come on. There we go, just a little bit closer. I think, okay, that'll do. That'll do, pig. Okay, so now we can do the, try the auto router. So I use free routing. And hopefully, okay. Hopefully everything, so all that's left is ground because it knows we've got a ground plane. Okay, so now let's fill in all zones, and there we go. Should be okay now. We can run the where is it? Inspect, design rules checker. What have I done wrong? Text thickness out of range. Oh, okay. True type Is it true type? Font characters with insufficient stroke weight. PCB box. Okay, but other than that, it seems happy. So it just doesn't like the font. So I'm using Consolus here, so that everything's in line. If I use the KiCad font, so if I use the default KiCad font, it's not. It's proportional. See, everything's messed up. So I want to use a what's the word? Proportional fixed font. So I normally use Consolus, but it's not happy about it for some reason. Anyway, there we go. It's done. Basically done. So now what I'll do is I've got the PCBWAY. Thanks again. So I've got two PCBWAY plugins. So one of them will generate all the fabrication files on your computer, so you can upload them to GitHub, or you can upload them to PCBWAY by yourself or some other fab. And there's another one which will upload the files directly to PCBWAY for you. So I can't remember which is which. So I'll just do some experimenting and then I'll be able to tell you. Right. So tools. So you can install these plugins very easily from the project manager here. So you've got the plugin and content manager. And you go over to fabrication plugins. So you can see here you've got the PCBWAY plugin for KiCad, and then you've got the fabrication toolkit. So the fabrication toolkit is the one that will store the files on the computer for you, and this one will upload them directly to your PCBWAY account. So I've got them both installed. So you just install them there and apply pending changes. So same with what I've done for the free router. So we just go to tools and then fabrication toolkit. So they'll generate the files on my machine. So we've got a BOM, got netlist, position, so that if you want them to actually put the parts on the PCB for you, and obviously the Gerber, however you pronounce it, files. So that's that one. Or we can go and upload it straight to PCBWAY. Here we go. And there's my file. So $5 for 5. Depending on the size, normally you can get 10 for the same price. If it's not too big. Yep, so I can get 10 for $5. And then, as I've been saying for ages, I use global direct shipping. So it takes about 2 weeks. Only costs $5. So for $10, I get 10 PCBs. And because I'm using the plugin in KiCad, they'll donate some of the costs to the KiCad project. So the only things if I want to do is, actually what I was going to do before I do all this is just double check the thickness of the PCB. I might do that. Otherwise, just original PCB is yellow, but that adds some time. Adds 3 to 4 days, maybe. But I'll go confirm the width, thickness first. Okay. Yep, I've measured it, so it's 1.6 mil, which is the default. So yellow, and should I go black text? That adds a bit. Oh, that adds a bit to the cost as well. I might just go green. Boring or green. With white text. Yeah, I'll do that. Okay. So last thing to do is just I'll print it out and just make sure it kind of everything fits. Okay, that's what it will look like. That's what the PCB is at the moment. Well, the cartridge on its own, and then in the case. So it's just a little bit longer. So it should fit in like so, and then plug into there, and assume it's plugged in. It'll look like that. We can put this is the top cover. So we've got we'll have a closer look. So we've got the EPROM sitting outside, so we don't have to worry about it getting caught on anything. And then we've got a little handhold, so we can just pull it out. So that should be fine. Should be fine. Yep, okay. We'll send it off and get it fabbed and give it a try. Hopefully that was of some interest. I certainly learnt some things. Okay, bye for now. Before we go, just doing some triple checks, and I've added in a little decoupling capacitor near the ROM just to give a little bit extra, like a local supply of power, maybe. And I noticed that the ground wasn't connecting through properly, so I've done some fiddling, and I think it's okay now, but I've noticed that the Autorouter is putting vias and tracks up in between the pads, and I want to keep those away. I just want the pads and then PCB, nothing else. I don't want anything in between that might accidentally short. So if we have another look, if we run the free router again, the Autorouter, what we end up with is, as you can see, we've got these vias up here in between the pads, and the reason for that is because the Autorouter, it thinks it has to connect to the middle of the pad. So maybe that's something I can fix, I don't know, in the footprint. I don't know where you tell it. Knock out. I'm not really sure. A position, pad stack mode. I'll need to read the instructions for all this fancy stuff. But that's the reason there. So if we fill in all the zones, you can see, yeah, see how ground. So this is the ground. Basically, this is the ground pin on the other side. But now it's completely disconnected because the Autorouter has sent the A11 signal from underneath along here up to here for some reason, and then down. So let's just unfill everything. So let's just manually move some of these tracks. So for a start, let's move this one down. Alright, maybe move it across a little bit. No, I'll just leave it there. Now if we fill in all zones, now we've got the ground is connected through. A little bit narrow there, so we could maybe we could move this over a bit, perhaps. Now, yeah, we've got these other ones up here, so let's just move them across like that. That's much better. Hang on, there, and this one, let's just move this down here, out of the way. That's better. Same with this one here. That looks alright. And move this one down. And can we move that one over? There we go, good. Yeah, I guess that's alright. This one's a bit trickier because we've got this via here and we've got this track underneath, so I don't know, can we bring this down a bit further? Well, we don't like right angles, do we? And then if I bring this down a bit, can I bring it down at all? Because the problem is if I try and it just does that. Alright, let's hang on, let's try something else. So let's just double click on it. And okay, Y position, so and -34. So I think -34 is up the top here. So if we just change that, I don't know, let's knock let's knock 10 mil off it. Oh, okay, it's down there. Right, let's add, so let's try that. Okay, that's a bit closer. Can I connect it in now? No. No, it wants to do that. All right, let's move it up a bit more. Okay, can I just? No, I just want to move this point. Ah, and we're back to where we were. So yeah, I'm going to fiddle around with this a bit more, but yeah, I think now that we fill, okay, a little bit narrow there, but that's probably a bit better. This is the VCC. Can you just connect into the, oh, maybe that's good enough, because that's a filled zone on the top. That should be good enough. Okay, there we go. So it's just about done. As I say, just do some manual changes there just to get the pads kind of clear. Okay, well, thanks for sticking around. Hopefully you learnt something. Bye for now.